Hi class, this is a movie on solving a word problem using linear programming. In this example we have for a given week, David's Coffee House has 1728 ounces of grade A coffee and 1760 ounces of grade B coffee. These are blended into 1 pound package as follows. An economy blend contains 2 ounces of A and 10 ounces of B. A superior blend contains 9 ounces of A and 2 ounces of B. The remainder of each blend is made of filler ingredients. There is a $3 profit on the economy blend and a $4 profit on each superior blend package sold. Assuming that the coffee house is able to sell as many blends as it makes, how many packages of each blend should be made to maximize the profit? I'm going to open up MathType to record the information as if I were writing it on a piece of paper so that you can see how I capture the information to do the word problem. So I have 1728 for the grade A coffee and 1760 for the grade B coffee, and that was in ounces. And I've also captured that the economy, I needed 2 of A and 10 of B, and for the superior it was 9 of the A blend and 2 of the B. And they also said that the profit was $3 for the economy blend and 4 for the superior. I'm going to hold on to that information till later. Let's just work on the first piece. In the problem, they ask us to find the economy blend, the number of packages, and the superior blend, the number of packages. So in MathType, I've let X take on some of those variables. So I'll scroll up so you can see. So I let X be the number of economy blend packages and Y be the number of superior blend packages. And then I notice, since I look at this here, I say, ooh, 2 of the economy, which is 2x, and 9 of the superior, 9y, is all going to be the A, and that should equal that 1728. So I'm going to have 2x plus 9y is less than or equal to 28. Similarly, I'm going to do the same thing for the B. For the B, I have 10B, 2B, and 1760. So 10x, because that's the economy blend, 2y, that's the superior, should equal 1760. Now I have 2 inequalities and 2 unknowns. And this problem, they ask us to use the graphing calculator to solve the problem. There's another implicit equation or inequality that's given. Because we're talking about blends or packages of coffee, it wouldn't make sense to have a negative coffee value or a negative number for the blend of the superior. So even though it's not stated explicitly, it's understood that the X is going to be greater than or equal to 0, and that's also true for Y. Meaning that our answer should only be in the first quadrant. We're going to solve for Y in the first equation, so I'm going to subtract 2x and divide by 9. In the second inequality, we're going to subtract the 10x and then divide by 2. And that will leave us with 1760 minus 10x divided by 2. And then we'll use the graphing calculator to graph those points and see the points of intersection, and then we'll go back to the part that I had erased earlier, which was our profit equation, and not a profit equation, but our profit information, because I didn't write down anything yet, to find the answer to the problem. So let's first graph it to find the region. Selecting y equal, we had 1728 minus 2x over 9, and then we had 1760 minus 10x divided by 2. We're going to also include y equal to 0, and then we're also going to draw the line x equals 0. I think I hit line value. I didn't mean to hit line value cancel. I meant to hit draw. And draw the line x equal to 0. So now we have x equal to 0 and y equal to 0. The other two graphs aren't visible, so we're going to zoom out so that we can see the two inequalities. Remember, there were 1760 and 1728, so those are big values. And now we have it. So if I were to graph the region or draw the region, it's going to be everything above the x-axis, everything to the right of the y-axis, that's the line x equal to 0, and y equals 0 is everything above the x-axis, less than or equal to our two other lines. It turns out the maximum profit is going to occur where these endpoints, or what we call vertices, occur. So at 0, 0, this x-intercept, the point of intersection of the two lines, and the y-intercept. So let's go ahead and find the the intersection of the 2 points. So I'll find our intersection, and we get 144, 160. So let's capture that in math type. So my bold line was y2. So I need to find the x-intercept for the bold line, and that's the equivalent to finding the intersection between y2 and y3. You say, well, why is that? Well, if y is 0, that's how we find the x-intercept. So my x-intercept is 176.0, and now we're going to find the y-intercept. To find the y-intercept, we're really looking at this value here when x is equal to 0. So we could substitute in x equal to 0 into y1, our first line, or we can also use a tool on ALEKS, which is called the value. So I'm going to find the value when x is equal to 0 for y1, which was the line that was not bold. And we have a value of 0 and 192. So we have a y-intercept of 192, that is when x is 0, y is 192. X equal to 0 is another x value for the vertice when y is equal to 0, which was the origin. So that would be our other vertice. We're trying to maximize the profit, and we had earlier that profit was given by $3 for each of the economy blend packages were sold and $4 for the superior. So if we have 3x plus 4y is the function we're really trying to maximize, and I'm going to call that z. We're going to figure out which of these ordered pairs, 144, 160, 176, 0, 0, 192, or 0, 0 will maximize this equation, 3x plus 4y. And we clearly see that, 0, 0 is not going to maximize. 3 times 0, 4 times 0, you're not producing any packages in any blend, so therefore you're not going to make any profit. So that we can just throw out. So let's take a look at 0, 192 and see if that will give us a larger value. So we're going to take 3 times 0 plus 4 times 192. And we'll go out to the ALEKS calculator to do 4 times 192. Equals 768. Let's go ahead and substitute in our second ordered pair, which is, actually I'm working from the bottom up, aren't I? So I guess it is second, no matter whether you're going from the top to bottom. So let's substitute in 176 for x and see what happens. So 3 times 176. And then plus 4 times 0 is just going to give you 0. So we just only need to do the 3 times 176. 528. And then let's try our intersection point, 144 and 160. And it looks like clearly it's going to be a winner because 3 times 144 and then 4 times that 160 is definitely going to work out. So we take 3 times 144 plus 4 times 160. And we get 1072. So we get 1072. And so we can see that 144, 160 will maximize. Well, 144 represented X, which was our economy blend. And 160 represented our Y. Let's do one more. So a manufacturer produces 2 models of airplanes. It takes the manufacturer 20 minutes to assemble Model A and 10 minutes to package it. And then it takes 25 minutes to assemble Model B and 5 minutes to package it. In a given week, the total available time for assembling is 3,000 and the total available time for packaging is 1,200. Model A earns a profit of 13, Model B a profit of 6. Assuming the manufacturer is able to sell as many models as it makes, how many units of each model should be produced to maximize the profit for the given week? Using math type, I've captured what I'd write on paper. 20 minutes to assemble, 10 minutes to package for A, as we see in the first sentence and second sentence. 25 minutes to assemble and 5 minutes to package for Model B. It says that the total time is 3,000 minutes to assemble and 1,200 minutes to package. And then they give us the profit equation, 13 for A and 6 for B is our profit. And they want to know the units for Model A and the units for Model B. So I'll let X be the units for Model A and Y be the units for Model B. So I know that 20X, because that's Model A, plus 25Y, because that's Model B, is going to be less than or equal to 3,000, because that's the assembly. You can think of that as the assembly column. Matter of fact, if I move this over, that even looks more clearer. There we go. So 20X plus 25Y less than or equal to 3,000. And then for our second inequality, we'll have 10X and 5Y is less than or equal to 1,200. We also have that X is greater than or equal to 0 and Y is greater than or equal to 0. We're going to solve for Y in the first equation, and we have, if you subtract that 20X, we'll have that Y is less than or equal to 3,000 minus 20X, all divided by 25. Similarly, we can solve for Y in the second inequality, subtracting the 10X and dividing by 5. So 1,200 minus 10X, then divided by 5. We'll graph this using the ALEKS calculator, find our vertices, and then determine which one will maximize the profit. 3,000 minus 20x over 25. Two inequalities, and then y equal, or two equations, and y equal to 0. We'll graph and zoom out. I've also graphed the vertical line x equal to 0 and the horizontal line y equal to 0. So intersect between y2 and y1. Let me go out there and make this one green, blue. There, I can see which one. Okay, so I need the black line. So the black line is y2. All right, so we'll first find the intersection point. So the intersection point is 140, and then the intersect is 120. So let's capture both of those on math type. So our third vertex is with the blue line, and that's going to be the y-intercept of the blue line. So we're going to find the value when x is equal to 0. And the blue line, I believe, was the first line. Yeah. So 0, 120 is going to be our third vertex, and we don't need to check 0, 0 for profit. Our profit was 13 for the model A and 6 for the model B. So we have 13x, where x represented the model A, and then 6b. And y represented the model B. So we'll plug in those values, and when we do 12 times 13, I don't believe that's going to be bigger than 100 times 13 plus 6 times 40. And 6 times 12 is 72. So clearly that's not going to work either. So the biggest one's going to occur at 140. Now some of these problems, they don't always give you profit. Sometimes they ask you to minimize. So you can't just always assume that it's going to be the intersection point. You really do need to test the values. So when we do 13 times 100 plus 6 times 40, let's do that on the calculator. That gives us 2140. So that's going to give us our maximum value. So when x is 100 and y is 140, that's when we're going to maximize our profit for producing these models. So I hope this, oh no, you got to be kidding me. What did I do wrong? Oh, it's 40. I think I put 140. So I hope this movie, oh, what? Oh, I just said be careful. That doesn't always work. Oh my gosh. I should have checked it and I didn't, so I apologize. So 13 times 120 does give a bigger value. And so it did occur at the intercept. So my fault for not checking. So I hope this short movie on, well, not so short movie, on solving a word problem using linear program was helpful. Alrighty, bye-bye.